Good thing I just flushed all those pills down the toilet. And I'll just wash my hands right now. Use some soap. Ever wonder where all the water's going? Well, this video, we're going to talk about it. So what happened to that water? That medicine didn't exist, don't worry. The soap did exist. And anything else that may come out of that faucet and go back down that drain. Well, in 25% of American households anyway, you're talking about it going into a septic system. I don't have a septic system. However, we still have drain pipes here that go out for sewage, for example. We can go all the way over here. And you can see this pipe there. And it'll feed into this larger pipe that we have here in this garage. Septic system will go out to the backyard, actually, or somewhere where there's a tank often. We have a septic tank often. There's different types of systems, by the way. And what happens in that tank is the lighter things, density-wise, will be on top. The solids will collect in the bottom. You'll have to have someone come and clean that out after a certain amount of time. And the effluent, which is the liquid that flows out, can go and get treated a little bit more, maybe in a drain field with going through some gravel. That's one way that this happens, or trickling through the soil. And there are types of filters that are used as well, and also some bacteria that might be in that tank and that we try to encourage. And so if you had chlorine, you don't want to really put it down your drain if you have a septic system. But again, for me, we have a central sewage treatment plant here, wastewater treatment plant, that services this area because it is a little bit more densely populated. And I'm going to show you something that's really a misconception as I go out into the street. So as promised, we are out in the street. And this is not a sewer. It is not part of the sewage system. It does say no dumping drains to the river. That's important. It's pretty dry. Won't be dry soon. It's raining at the moment, actually, and we're at the base of a hill. That is a storm drain. It is not in this place, in this municipality, connected to the sewage system. 1,200 cities in the United States, it is. And worldwide, much different. We need to have another conversation another time. There are open gutters and all sorts of things. But in this country, most of the time, they are connected. They're not connected in terms of the sewage system, the pipes, and the storm drains. They are separate. And this is good. This is what we actually want, because sometimes they will overflow in a storm. You know, this is the, actually, if you can see the wonderful sky here, it may rain substantially today. It's the remnants of a hurricane that's coming up the coast. So, that wouldn't be good if you mixed in sewage with a substantial amount of water, and that does happen when they are connected that way. But most of the time that is not the case, although in 1,200 cities in this country it is cheaper, so that is what we do. So where does it go next in this wonderfully drawn, generalized sewage treatment plant? Will help us out. Maybe. Yeah, just pretty bad. But anyway, primary treatment. Primary treatment deals with physical means to clean up and treat that wastewater. So you got the sewage coming in, like I said, from a separate pipe, hopefully. And it's going to go through some screens to filter out the larger pieces. So when you flush down that action figure to go and save the people in the toilet, well, that's hopefully where it gets to if it doesn't jam you up. And then it will be physically removed. And you can put some lime and stuff on the physical pieces that wind up being taken out by the screens. But not everything is. So we move it through these chambers, like a grit chamber, like these big tanks, really. Tanks of water. And they move slowly. So because the solids are more dense, they're going to eventually settle out, and we can remove them at different points and put them maybe into the sludge field. The grit chamber is the first of those tanks. Often I've seen a chain on the bottom of some of them that makes it move a little faster. Not fast. Again, we want the water to move slowly, but it really won't move too much if it doesn't have the right incline, the right slope, or some physical means of getting it to move. So that chain is that. So the chain will move it along a bit. Then we're still in primary treatment, and we have a primary clarifier. Clarify, make it clear. So again, we're letting things settle. You'll hear them called settling tanks as well. And the sludge, in this case, it's raw sludge. We're just going to take it out, put it into a sludge field. It can actually be used. And we'll talk about that in a second because there's problems with that. You also have a secondary treatment, which means now we're using biological and chemical means to help treat the water, not just physical. So the aeration tank, we're going to use an air compressor. We're going to put some air bubbles like you would in a fish tank with the diver or the treasure chest or whatever. Put some bubbles into that tank, and not only are we letting things kind of settle out, but in this case, what we're really doing is we're creating an environment that bacteria that are going to break apart some of that organic matter and start getting rid of it and treating the water for you, giving them an environment that they like, a place to live. The secondary clarifier is also going to clear the water up a little bit more. And the things that settle out in the bottom, that's not going to be activated sludge because we'll have the bacteria in it because we got it out of the tank with the bubbles. So we're going to bring that back around to the aeration tank and have that sludge keep going like that in this cycle. The extras will go into the sludge field. At that point, after the clarifier, the secondary clarifier, we're going to use either, that should be, we're not going to use oxygen. That really won't do too much. We're going to use ozone. So there we go. That's a 3 now. So O3, ozone, or UV light sometimes, or some kind of chlorine, including sometimes bleach and all sorts of different ways nowadays. We try to stay away from gas because chlorine gas can be used by bad people. And that helps to disinfect the water. But then hopefully we make it into tertiary treatment. We're going to talk about that next. Okay, so let's talk about that tertiary treatment and what actually is not done by all this lovely, horrible diagram. What is not done is if we have a lot of fertilizers in the area, like if we have a lot of nitrates and phosphates and stuff like that, really need tertiary treatment in order to, there's special filters that can take that out of it, because that actually can cause eutrophication of water bodies nearby. And cultural eutrophication can cause a pond or lake or whatever to basically over time to fill in, to get very green for a while with a bunch of algae, and then basically kill everything in the aquatic ecosystem and become a terrestrial one over a longer period of time. A shorter period of time than it would happen naturally, of course, because naturally that happens too. Also, things like your medicines that I pretended to flush down the toilet, they're not getting treated by any of this. And you would need special tertiary treatment in order to deal with them. You know, I use the soap again. You know, soap can have some phosphates in it too. So there are things, especially in various communities, and this is a problem. And one of the problems is, as we talked about before, if we're going to have a sludge field, that we take some of that sludge out, we take some of the biological material and use it to help grow crops, for example, which there are no laws against. You might have toxic metals in it because this doesn't do anything to get rid of toxic metals. You might have those medicines. You might have, again, the nitrates and phosphates might be released, because what's going to happen next after this as well, after the tertiary treatment, is it goes out into a local stream, an effluent stream. So I'll just draw a little, that's my hand, yes, okay. Here's the stream, that's it. Wonderful drawing, I know. So it might go into an effluent stream and then get back into the environment as well. So we do have to worry about going back into the environment, also being reused by humans in a way that, again, is legal, but we didn't really treat all of this water and the organic material for to make it safe at that point. So that is something that should be considered.